Example 1. Given the triangle, state the ratio sine, cosine, tangent, and their reciprocals from theta. Before you really start the problem, you really need to label your triangle. So down here at angle C is our 90-degree angle, which we can tell from the picture, which means if we start at the 90 degrees and go through the middle of the triangle, the side we hit is known as the hypotenuse. If we then go to theta, where we're going to base all of our adjacent and opposite from, take your pencil, draw a line through the center. The 3 will be your opposite side of angle A, and the 2 will therefore be your adjacent side. Now if we go to our trig ratios, we have sine theta, which is opposite over hypotenuse, so 3 over the square root of 13. Now remember, we don't want to have a radical in the denominator, so we're going to multiply the numerator and denominator by the square root of 13. So you'll have 3 square root 13 over 13. We have the reciprocal for sine, which is cosecant. And reciprocal simply means you take this fraction here, 3 over square root of 13, and you flip it. So it's the square root of 13 over 3. There is no radical in the denominator, so you don't have to do anything else to that number. If we go on to doing cosine, cosine is adjacent over hypotenuse, so 2 over square root of 13. Once again, we have a radical in the denominator, so we are going to multiply top and bottom by the square root of 13. We will then get 2 square root 13 over 13. And the reciprocal for cosine is secant. And we are just going to flip the fraction 2 over the square root of 13, so it is the square root of 13 over 2. We then have tangent, which is opposite over adjacent, so 3 over 2. There's no radicals in the denominator, so there's nothing to do to that number. Then its reciprocal, cotangent, will be the reciprocal. So you would have 2 over 3. And now you have stated all 3 of your original trig ratios, and then your reciprocals that are marked in purple. Example 2. Find the missing angle measure, round to the nearest whole number. This will require a calculator. You cannot do this problem without one. So, first thing we should do is label our hypotenuse, our opposite, and our adjacent. So starting from the 90 degrees, if we draw a line through the center of the triangle, we hit the hypotenuse. If we start at the angle that we are looking for, which is the question mark, we are going to draw a line through the center. The side we hit is 47. That will be the opposite side. And therefore the 24 will be the adjacent side. So the only sides where they give us information for is the opposite and the adjacent. Opposite and adjacent is tangent. So we're going to have tangent -1. And then inside our parentheses, we'll have our fraction of opposite over adjacent. Now the way we get our calculation in the calculator to get the angle degree, on our calculators, we're going to hit the second button. Then you're going to hit tangent. And then on your screen, you're going to see tan -1 pop up like this. You're simply going to type in 47, divide 24, close your parentheses. And when you do that, you're going to get the answer of 62.9. 62.9. Now the direction said round to the nearest whole number, so it's 0.9, so that's greater than 0.5. So we're going to round up to 63 degrees for our angle that with the question mark. Now this can change based on what do they provide. Sometimes you'll use the inverse of sine or the inverse of cosine. It will not always be tangent. So make sure you're labeling your sides to know what have they provided. Example 3, find the missing side of the triangle. So As we've done with many of our problems, we are going to label our sides. If we start at the 90 degrees, draw a line through the center of the triangle, we're going to hit the hypotenuse, which is where our x is. If we go to the angle degree that they provide, we draw a line through the center, we hit the side, we hit 13, that's going to be considered our opposite side. And then our last side is the adjacent. Now, the only sides that they provide any information for is on the opposite side and the hypotenuse. The trig ratio that is opposite and hypotenuse is sine. So we're going to use sine of 51, that's our degree, equals our opposite, which is 13, over our hypotenuse, which is x. Now we need to go ahead and solve for x. We're going to multiply both sides of our equation by our denominator. The x here and the x here will cancel each other out, leaving x times sine 51 equals 13. X is not by itself yet, so we're going to have to divide by sine of 51, not 51, but sine of 51. Those are going to cancel out, so you're going to have x equals, and then we're going to type this into the calculator. So we're going to type in 13 divide sine 51, hit enter, and you're going to get 16.72. It asks us to round to the nearest tenth, so this number is lower than a 5, so it's just going to be 16.7 for our side. All right, you're going to have a few word problems. Our first one is going to be dealing with elevation. It says, Cindy looks up at the top of the tree at an angle of elevation of 39 degrees. She is 24 feet away from the tree. What is the height of the tree? Round to the nearest tenth. So you'll notice in our picture below, we can see the distance that she's from the tree is 24, that her eyesight from her eyeballs to the ground is actually 5.5 feet, which we'll have to deal with to actually find the height of our tree, which is h. But first, before we can do that, we really need to find this height right here. We need to find this height. It's not the whole height of the tree. It's part of it, though. I'm just going to call that x. Now, as always, I'm going to go around and label my triangle. Starting from the 90-degree angle, this would be the hypotenuse. Starting from the degree they give me, going across, this x will end up being our opposite side. And then we have our adjacent side, which is the distance from where Cindy is to the tree. Now, they have provided information for the opposite side, which is our x, and the adjacent side, which is the 24. And so if we have opposite and adjacent, that's tangent. So we're going to have tangent degree of 39 equals x, opposite over adjacent. And now we're going to go ahead and solve for x by multiplying both sides by 24. The 24s are going to cancel out there, so we have 24 times tan 39 equals x. Now x is already by itself on the right side, so we're just going to go ahead to the calculator and type in 24 times tan 39, and we're going to have 19.43. Now it said round to the nearest tenth, so it's really going to be 19.4 for x. But that is not the height of the tree. All we did was find the height of the blue line that I drew there. Keep in mind that she's looking directly at the tree. We have to account for her actual height from her eyeballs to the ground. So we have to include this 5.5. So 5.5. We're going to add those together to get the height. So 19.4 plus 5.5 is 24.9 feet. So our tree is 24.9 feet tall. Example 5. Jimmy is on top of a slide. The slide has a 35-degree angle of depression. The slide is 10 feet long. What is the height of the slide? So keep in mind with angles of depression, the angle of depression is referring to the angle that is right here. However, you'll notice our triangle doesn't have any angles written in it. That is because you actually need to find this angle. It's pretty simple. keep in mind that these two angles, the one that I've marked in purple and this one right here, are actually going to add up to 90 degrees. They will always add up to 90 degrees. So therefore, 90 minus 35 is going to give us 55 degrees. We are going to use the 55 degrees to solve our problem, not the 35 degrees. But we need that 35 degrees to let us find the 55. So now we're going to go ahead and label our triangle like we always do. This is obviously the 90-degree angle going across the middle of the triangle. The 10 would be the hypotenuse, starting at the 55, going through the center of the triangle. Down here would be the opposite side, and the x will be the adjacent side. Now this time they have provided the adjacent side with an x and the hypotenuse with a 10, which means we have cosine. So cosine 55 equals x over 10. We're going to get x by itself by multiplying the denominator to both sides. So now we have 10 times cosine 55 equals x. Since x is all by itself, we're just going to type in 10 times cosine 55 into the calculator, and we get 5.73. 5.73. Now it said round to the nearest tenth. Since this number is less than 5, we're just going to round down to be 5.7. So the height of the slide is 5.7 feet. All right, so example 6 says given the 45, 45, 90 triangle, find all the missing sides. Write the exact answers, whole numbers, and /or radical. So this will be a multiple choice question on your test, because sometimes your answers will have radicals, the square roots that you've been seeing in the past few days. So as always, I always recommend is, even though they put in variables here, when you do the math, I would just act like they're not there, maybe even draw it out a second time, but not have those variables. And the reason why I say that is the way I taught you was always to label your triangle. If this is a 45, 45, 90, that means this side here and this side here are x's. And this right here is x square root 2. This is going back to our reference triangle for 45, 45, 90. Now that we have the reference triangle set up, we can see that the 7 is equal to the x square root of 2. But we actually need to find out what x is so we can find the two legs over here. So we're going to go x square root 2 equals 7. We're going to go ahead and divide both sides by the square root of 2. We're doing this because we want to get the x by itself. Those will cancel. So we're going to have x equals 7 over the square root of 2. And just like other problems, we don't want a radical in the denominator. So we're going to multiply the top and bottom by the square root of 2. Which means we have 7 square root of 2 over, since the 2's repeated themselves, we're going to have a 2 on the bottom. Which means our x for this problem is 7 square root of 2 over 2. Well, here's an x, so that's 7 square root of 2 over 2. And here's an x, 7 square root of 2 over 2. And now you've found all the sides of the triangle. Example 7, given a 30, 60, 90 triangle, find all the missing sides. Write exact answers, whole numbers and or radicals, just depending on the problem. And just like before, I would ignore these variables at the moment, and I would set up my own like so. And if this is 60, that means this one has to be 90. And therefore, if we use our reference triangle, across from the 30 is going to be our x, across from the 60 is x square root 3, and across from the 90 is 2x. So here we can see that the 12 is equal to the 2x. So we can ask ourselves 2 times what number would equal 12? It would be 6. Or you could just set up like an equation and solve it. So x would equal a 6, which means you now know what x is. So this x is actually a 6. Anywhere you see an x, you should make it a 6. So this x now is a 6, like so. So this side of the triangle is x, so your n is 6, your m is 6 square root 3, and you already have the 12 for the hypotenuse. Example 8, use the geometric mean to solve for x. So the geometric mean is taking the length of this part and the length here and multiplying it together and square rooting it to find our x. Well, if we know the total length from here to here is 100 and the green part is 64, that means the red part would be 36, because 36 plus 64 is 100. You can figure out 36 by simply going 100 minus 64 to get 36. So our geometric mean would be x equals the square root of 36 times 64. So you just go to the calculator, go 36 times 64 is going to be 2,304. And then we just go ahead and square root it in our calculator, square root 2304, and we get 48 with no square root. It's just the number 48. And that's how you use the geometric mean to find this length, our altitude.